This is the solution video to question 11 from section 5.3. A man on a dock is pulling in a boat using a rope attached to the boat, to the bow of the boat, 1 foot above water level, and passing through a simple pulley located on the dock, 8 feet above water level. If he pulls the rope at a rate of 2 feet per second, how fast is the boat approaching the dock when the bow of the boat is 24 feet from a point that is directly below the pulley? All right, so I have it labeled a little bit. Okay, now the pulley is 8 feet above the water level, but you're told that it's attached to the bow 1 foot above water level. So obviously, this side of the right triangle is 7 feet, right? And that is not changing, right? That is fixed. Okay. But this 24, that is changing, right? So we need to give a variable to that, right? Because the boat is moving towards the dock, right? So let's give this X, all right? And I'm going to call that R for rope, all right? Because that is changing as well. So X is changing. So there is a dx dt, right? Which is some negative value, right? Because this is decreasing, all right? And this is actually what we want to know, right? It says how fast is the boat approaching the dock, right? So that's what we want to know. R is changing, so there is a dr dt, right? Which is also a negative value because the length of the rope is decreasing. And you're told that he's pulling the rope in at 2 feet per second. So negative 2 feet per second is dr dt. All right. So now how are R and X related? Well, um, once again, by the Pythagorean theorem, right? So you can say that x squared plus 7 squared is equal to r squared. All right, so what is our find statement? Well, it said to find how fast the boat is approaching the dock. So dx dt, when what is true? Well, when x is 24. All right, so we've got our equation here. So let's take the derivative. 2x dx dt plus 0. Remember, the derivative of 7 squared, or 49, is 0, equals 2r dr dt. All right. And so now we want to plug in the values that we know. Okay, we know dr dt. We want to find dx dt. We know x, but we don't know r. So this is where we need to use the Pythagorean theorem. So we want to know x. Sorry, we know that x is 24. So 24 squared plus 7 squared equals r squared. So r ends up being 25. Okay, obviously you can solve this using the Pythagorean theorem, or you can remember that there is a special right triangle, a 7, 24, 25 right triangle. So r is 25. So now I'm going to plug in those values. So 2 times x, which is 24, times dx dt, which is what we want to know, equals 2 times r, which is 25, times dr dt, which is negative 2. Don't forget about the negative sign. All right, so now we're going to divide by 24. So dx dt, all right, is 2 times 25 times negative 2 over 2 times 24. And so I reduce the 2's. I've got a 2 and a 24, so that can become a 12. So I've got a negative 25 twelfths, right? And so that is our value. Now, what are the units? Well, remember, this is the rate at which a distance is decreasing. So that would be the unit of distance is feet, and the unit of time is seconds. So negative 25 twelfths feet per second.